got a sequence here and we're working out the next term. Hint, this is question 16, so it's probably not going to be a linear sequence. It's also not a quadratic. You have to realize that this is a geometric sequence and we're multiplying by root 3 every time. We just check it. 5 root 3 times root 3 is 5 times 3, which is 15. It works here as well, so we can be pretty confident. And so the next term is going to be 15 root 3 times root 3, which is 15 times 3, which is 45. Find the nth term. Okay, we can see that we're going up by root 3 every time, so it's going to be a bit like root 3 to the power n. I'm going to explain this in two ways now. So root 3 to the power n, now that doesn't quite work at the moment, because if I let n equal 1, I'm going to get root 3, and I don't want root 3, I want 5. So I'm going to need to multiply by 5 divided by root 3, because that will sort it out. I'm just going to say that one more time. My first term, I know it's powers of root 3 because I'm timesing by root 3 every time. A bit like the fact that 2, 4, 8, 16 would be 2 to the power n. But that one's okay because the first term when n is 1 is 2. It's not here, it's root 3. So I need to basically divide by root 3 to get it back to 1 and then times by 5, and that will sort it all out. Now I can simplify this, because if I have x to the n and I divide by x, it's equal to x to the n minus 1. And so this is going to be very similar. The nth term is going to be 5 and then root 3 in a bracket n minus 1. Okay, just very quickly, another way you can think about this question that helps, I think, is just like for a linear sequence, when you have, say, 3, 5, 7, we can see that it's going to be 2n because it's like the 2 times table, but then we can look at the 0th term to help us out. That's our starting term, it's 2n plus 1. For the geometric one, it's very similar. I know that it's going to sort of be root 3 power n, like I said before, but now if I look at the 0th term over here, I need to divide it by root 3, and it's going to be 5 over root 3. So when n is 0, I'm expected to get 5 over root 3, so I would times that by 5 over root 3. I get exactly the same thing as I got here. I'm just explaining it in a different way. Instead of sort of looking at this and thinking, what do I need to do to get 5 as my first term, I'm using the 0th term to help me out. In both cases, I then need to simplify to this.